Okay, let's do some more problems. This is problem 2. A construction worker pulls a 5-meter plank up the side of a building by pulling one end straight up while the other slides on the ground. So if we imagine that, let's say that this corner over here is the side of the building right here, and then the ground right here. So basically what happens is that there's like a plank lying on the ground there like that, and then by pulling this side goes up while this side gets closer and closer and closer to the building. If the worker pulls up at a rate of 0.15 meters per second, how fast is the bottom moving along the ground when the bottom is 2.5 meters from the wall? Okay, our first thing is going to be to find our rates. Worker pulls up at a rate of, so up, that's the y direction. How fast, that's another rate. Is the bottom moving along the ground? So moving along the ground, that's moving this way. That's in the x direction, so this is dx dt. So now let's draw a picture. We've got our little person standing here. We've got a board. And so, like we said, the person is drawing this plank like this. So that means that the distance between the bottom of the plank and the building, that's an x distance. That's changing. That's our dx dt that we're interested in. And then this distance that's being pulled up, this y is changing as well. So those need to have variables. The plank is 5 meters long, so we can just label that. And now I need to write some sort of equation that's relating these two. We know this is a right triangle again, so we know that x squared plus y squared equals 5 squared. This is because it's a right triangle. So we want to work with rates, so that means we can take the derivative with respect to time of each of these. So it's the same things we were doing in the previous problem. Now we have some knowns and some unknowns. We know the bottom is 2.5 meters from the wall, so that's x equals 2.5. That's distant right there. We know that the worker pulls up at a rate of 0.15 meters per second, so that's dy dt. We want to find how fast the bottom is moving along the ground, so that's dx dt. And we can just plug those right in here. Now, one of the things we notice here is that we don't know what y is. Y isn't something we're trying to solve for, but it's something that we might need to find in order to do this. So I'm just going to leave a little spot for y right now. dy dt we know is 0.15. So we need to find y. Now we can do that because notice that we have an equation relating x and y. If we know what x is, then we also know what y is. X we know is 2.5. (2.5) squared is 6.25. Subtract 6.25 from both sides. And because we're working in the real world, we're just going to leave the square root like that. It's going to be a positive square root, not a negative, because we can't have negative distance. Okay, so now I can do more with this. We can subtract that from both sides. Divide both sides by 5. And there we go. This negative right here means that the rate of change is in the negative direction for x. It means toward the left.